This video corresponds with Lesson 9 in Unit 4A, dealing with using the quadratic formula to solve quadratic equations. The quadratic formula can be used to solve any type of quadratic equation, no matter if it can be factored or not. Kind of similar to the process of completing the square, but it has its own special little formula. So you can see at the top right here, this formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. It's a convoluted looking formula, but if you can identify what a, b, and c are, it's a matter of just substituting into the problem and solving for the solutions for x. In order to use quadratic formula property, the equations must be set equal to 0. Once they are set equal to 0, it's a matter of just identifying your a, your b, and your c terms. So the a is always with the x squared, b is always with the x, and the c is your constant. So it's the number that has no variable attached to it. So in the case of the first example here, 4x squared minus 8x minus 5 equals 0. 4 will be the a term, negative 8 the b, negative 5 the c. So we are going to go ahead and use that quadratic formula from the top. Now I'm just going to substitute everything in. When you substitute, I highly recommend putting everything in parentheses, especially your negative terms, just to make sure everything is correctly substituted. So we start with negative b, so it'll be negative 8 plus or minus big square root sign b squared, so negative 8 squared, minus 4 times a, which is 4, times c, which is negative 5, all over 2 times the a value, which is 4. So first thing you need to make sure to do with quadratic formula, simply write out where all the numbers should be. And again, when you substitute, I would highly suggest, especially because there's so much to do in this process, put everything in parentheses. Now, we're going to simplify this here in 3 ways. Let's look at the very front of the problem. Negative 8, we know that's positive 8. Use your calculators. The nice thing about having everything put in parentheses nice and laid out here, as you can see underneath the square root, you can take all that underneath the root without the square root, punch that into your calculator to figure out what the number under the square root should be. So again, use your calculators here. You can do that all in one step. You can do a couple of steps of order of operations if you really want to, but again, for the sake of time and for the sake of efficiency, we're going to do negative 8 squared minus 4 times negative 5 all in one shot. So when we do that, negative 8 squared is 64. You have negative 4 times negative 5, which is 80. That would add up to 144, all over 2 times 4, which is 8. From here, you must simplify as much as humanly possible. So first thing we're going to do is look under the square root. Nice thing about the square root of 144 is that comes up really nice. If you're not sure, use your calculator to see if it comes out nice or not. Square root of 144 is simply 12. Since we have nothing but integers here, we're going to go ahead and simplify this in 2 ways, because we have 8 plus 12 over 8, and we have 8 minus 12 over 8. So all I'm going to do is branch it out. And again, you can show this step here, or again, this is a process you could just do quickly in your calculator or in your head, whatever you decide to choose. So again, we're going to branch it off here because everything's an integer. We can go ahead, it's all rational numbers. We can go ahead and simplify and get 2 very nice clean answers. So when we do this, we end up with 20 over 8, which is the same thing as 5 over 2. And we have negative 4 over 8, which is the same as negative 1/2. So my solutions would be x equals negative 1/2 or 5/2. Those would be my 2 answers for that. So when you do quadratic formula, sometimes you'll end up with a result like the first problem here, where it comes out really nice and clean underneath the square root, and it'll simplify down to a couple of pretty nice answers. Sometimes that's not the case, as you'll see here in the second example. Now in the second example here, one thing we need to take care of first is this is not set equal to 0. You can't do quadratic formula unless it's set equal to 0. So what I'm going to do really quick here is I'm going to add 25 to each side. And I'm going to rewrite this problem, as x squared plus 12x plus 25 equals 0. Now, We have it written so that everything's on the left. It's equal to 0. Great. Now we're going to have our three terms. So we got our A, our B, and our C. You'll notice there's not a number you can see in front of the x squared. That means the A is going to be a 1. So we have an invisible 1 there as our A term. Now I'm going to go ahead and repeat the same process that we did in the first problem. We're going to take all the values and go sub them in. So we start with negative b, so negative 12, plus or minus square root of b squared, so 12 squared, minus 4 times a, which is 1, times c, which is 25. All over 2 times a, 2 times 1. Again, I'll simplify this here in 3 chunks. First part here is what's in front of the numerator, so negative with a 12, well, that just becomes negative 12. Plus or minus, I'm going to do all the math that's underneath the square root. So 12 squared is 144. Negative 4 times 1 times 25 is negative 100. If I put 144 and negative 100 together, that comes out to 44. And I'm going to go ahead and do 2 times 1, which is 2. Now, there's not a lot more I can do with this, but again, we always want to look at the square root, as we've talked about for about half this chapter, and figure out, can it simplify down any further? So, if I look at square root of 44, okay, you can either write this off to the side or write this as 2 separate waves here. I can actually take square root of 44 and break it apart, so we have a perfect square of 4 and 11 to break it apart over 2, which means I'd have negative 12 plus or minus 2 square root 11 over 2. Now that in itself is a pretty good answer, okay, because again, we took the 44, we broke it down, we could pull a perfect square out of it, so we could have simplified that radical, and in some of these problems you'll do that. Now if I look really closely though, negative 12, that front 2, all being divided by 2, this can actually simplify just a little bit further. Negative 12 divided by 2 is negative 6, plus or minus 2 root 11 over 2 is root 11. So my final answer for x is negative 6 plus or minus the square root of 11. So quadratic formula, again, to kind of sum it up in a nutshell, it's another way to solve these quadratic problems. It's its own separate process from completing the square. You might see this as a little bit easier because it's very formula based. The main thing you have to keep in mind is that the problem must be equal to 0. You have to pull out the correct A, B, and C term, and it's just a matter of substituting and doing really good order of operations. You do that correctly, and these will be pretty easy to solve.